We're doing 7.3, warm up. Given Q contains the elements 0, 2, 4, and 6. W contains the four elements 0, 1, 2, 3, and Z contains the elements 1, 2, 3, 4. What is the intersection? They gave you the word here. Whoops, they gave you the word. Usually they give you the symbol, which would be this. So it would look like this if they gave you the symbol. So make sure you guys know the symbol for intersection in case they do that on the EOC. Intersection means what numbers do all of them have the same of that are in common or duplicates. It looks like only these two have 0, these two only have 1. We've got 2, 2, and 2. These guys only have 3, these guys only have 4, and that one only has 6. So the intersection is choice 1, which is 2. Multiplying powers with the same base, lesson 7-3. When you multiply with the same base, if you look at this, it says a to the m times a to the n. The bases are the same. The rule is to add your exponents. So a to the m times a to the n is equal to a to the m plus n. If you notice in the first example, the bases are both 4, so 3 plus 5, adding your exponents gives you 4 to the 8. You wouldn't leave it like this, but this comes out to a large number, so they left it alone at that point. 7 plus negative 4 is positive 3, so b to the third. The rule is anytime you multiply with same bases, if the bases are different, this rule does not work. Then you are going to add the exponents. Let's look at the first example. We're going to leave these because the bases and the exponents are going to be so large. We're going to leave them in exponential form, which means we're not going to multiply them out into standard. 8 to the third times 8 to the sixth, same base, so it's 8, and then you add your exponents. 3 plus 6 is 9. You wouldn't leave it like this. You would actually have multiplied it out. On the EOC or any test or quiz, they would make either your base smaller or your exponent smaller so that your final answer was not huge. Question B, the bases are the same. So you have 0.5, and you're going to raise it to add your exponents. Okay, let's start that again. Negative 3 plus negative 8 is negative 12. And then you can't have a negative exponent, so to get rid of the negative exponent, you're going to have to think about it like it's a fraction and flip it. Keep it in your parentheses and make it a positive 12. We're not going to multiply that out. It gets very big. All the bases up here are all 9, so the same bases. So we're going to leave it as 9 as the base. Add your exponents. Negative 3 plus 2 is negative 1, and negative 1 plus 6 is positive 5. We'll leave it like that. Okay? If one of those bases, 9, was a different number, then you could not. You can only add the exponents to the ones that have the same bases. You couldn't do it to the other one. You'd have to just drop that down, and we're going to see what that looks like in just a minute. Alright, so these are different because they're algebraic, which means now they have exponent or variables in them. When you have that, you're just going to multiply your coefficients across. 5 times 1 is 5, and 5 times 3 is 15. And then you look at your bases that are the same for your variables. They're all x, so you add your exponents. 4 plus 9 is 13, and 13 plus 1 is 14. That's the simplified, most simplified form. All right, go ahead and try B. Then take me back off pause and see how you did. Multiply your coefficients. Negative 4 times positive 7 is negative 28, and negative 28 times positive 2 is a negative 56. Then you have 2 of your variables have like bases, so those are the only 2 I can use the rule on. So you're going to end up with C. Add those exponents. 3 plus negative 2 is 1. I'll leave it as an imaginary 1. And then D squared drops down. Typically, they like you to write it in the order of, with your variables, the highest degree first, or exponent first. The third one, it's cut off here. There's a j over here, so I'll rewrite the problem. It's j squared times k to the negative 2 times 12j. So we get 1 times 12 is 12. We can only use the rule on our like bases, which are these two. There's an imaginary 1 exponent, so j squared times j to the first, adding your exponents, you'd get j to the third. And then, if you look at the k, it's a negative 2, which means to make it a positive, you have to flip it. So right now it's in the numerator. You have to flip it and put it in the denominator, which will make it a positive. There it is. All right, if they give you two numbers that they want you to multiply by scientific notation, you could change these back to standard and then multiply, and then go back to, because they want the final answer to be in scientific notation, or better yet, you could multiply your numbers. 3 times 5 is 15, and 10, same basis, 10 to the 5th times 10 to the 12th is 10 to the add 5 plus negative 12 is negative 7. The problem with this is it's not written correctly in scientific notation because the decimal point is right there. So if you think about this, what happened was if you go backwards on it, like you were going to put it back into English or standard form, they went 1, 2, 3, 4, 5, 6, 7. It started right here, and they moved it 7 places over. However, they really shouldn't have gone 7. They should have gone 1, 2, 3, 4, 5, and 6. So they should have stopped between the 1 and the 5, which would have meant that your decimal went 1 too far, so you should have only gone 6 places versus 7. And that will be the homework for tomorrow.